Hello viewers, welcome once again to my channel, Ojuk's Online Maths Class. In this channel, secondary school mathematics, physics and further mathematics are being covered serially. This will go a long way in helping students to go ahead of their scheme of work given to them in their various schools. So I urge teachers and parents to do well to recommend this channel to their students and kids so as to ease learning. Also, at the end of each class drill will be given for assessment. So do well to attempt the drill and as well drop your solution at the comment section for marking. Okay, today we'll be looking at the first topic in the scheme of work for SS1, which is the number-based system. What is number-based system? Just as we use petrol gauge to measure petroleum and also bucket, generally known as penta, to measure garri, we can also measure numbers or count numbers in bases. As we all know, the primary counting numbers are ranging from 0 to 9. Every other numbers emanate from the primary counting numbers. Let's just take for instance, this is the primary counting number, 0 to what? To 9. If I want to get every other number, let's say 556. 556 is gotten from this primary counting numbers, which is just the combination of 556. That is combination of 2 5s and what? Just 1 6. I will get my 556. Okay, if I want to get my 1 million, 1 million is simply the combination of just single 1 and 6 what? Zeros. So this primary counting numbers is known as our common base 10. So you can see in base 10, which is this our primary counting number, it is ranging from 0 to 9. The highest number that we observed in this base 10 is 9. The same thing goes for other bases. We count numbers not just in base 10, we can count numbers also in other bases. We have base 10, we have base 9, and the rest of the bases. So you can observe all these bases here, listed here. In base 9, highest number we observe in base 9 is just what? Just 8. You can see the range of values of what? Numbers in base 9, ranging from 0 then down to what? 8. The same thing goes for other bases down to base what? Base 2. The highest number you are expected to see in base 2 is just what? 1, which means that the common numbers that are which will be familiar when it comes to base 2 or the binary system is the what? Just 0 and 1. You can observe other bases. You have base 5, the quinary system. The highest number in the quinary system is what? Is 4. So whichever base at all you are working on, that particular base shouldn't appear in the list of numbers that are to be contained in the base. Okay, having known the concept of this number bases, can we now convert numbers from one base to another? Yes, we can convert a number from base 10 to base 9. We can convert a number from base 9 to base 5. We can even convert a number that is in base 2 to base what? To base 10. Which means it is very much possible to convert numbers from one base to another. So first of all, we want to basically look at how to convert a number that is in base 10 to other bases. How do you convert a number that is in base 10 to what? To other bases. Let us observe. If you want to convert a number that is in base 10 to other bases, it is very simple. What do? It involves repeated division. If you want to convert a number that is in base 10 to other bases, it simply involves what? Repeated division, of which your remainders are being collected from bottom to top, or from bottom to the top as your result. Let us solve an example. I have this number First example, convert 67, a number in base 10, to base 2, which is to binary. Base 2 is otherwise known as binary system. Convert a number 67, which is in base 10, to base 2, which is what? To a binary number. Like I said earlier, converting numbers from base 10 to other bases simply involves what? Repeated division, of which your results are being gotten from taking your remainders from the bottom to the top. Let us now observe the division of this. First of all, we'll draw our line for the division. 67 inside, then we have our 2, which is the divisor, outside. Then let us now repeatedly divide this to get our result. Remember, if you are solving question in base 2, or if you are converting to base 2, the highest number you are expected to see in base 2 is 1. So our result or our answer should be revolving around just 1 and what? And 0. Because of what? 1 and 0 are the what? The common numbers that are expected to be in base 2. Now let us divide to get our result. 67 divided by 2. We are having 67 divided by 2, we have 33. Remainder 1. Again, 2. We are going to use 2 to successively divide what? This, till we get to what? To 0. So 33 divided by 2, we'll be getting 16. Remainder 1. As you can see, 2 divides 16, we are getting 8. Remainder 0. Then 2 divides 8, we are having 4. Remainder 0. 2 divides 4, we are having 2. Remainder 0. Then 2 divides 2, we are having 1. Remainder 0. Finally, 2, you keep on dividing till you get your what? Result as 0. Then 2 divide 1, we are having 0. Remainder 1. Now, how do you collect your result? We have totally, or we have repeatedly divided this till we get to the final what? Result as what? Or to get to our final result as 0. So as we have gotten this, remember I said earlier that we are going to collect what? The result, your result, by taking your remainder from the bottom to the top. So as we have this, we will now list our result. Taking our result or counting our result from the bottom to the top, we are having 1, 0, 0, 0, 1, 2, 3, 4, then one more 0, then we have our double 1. This is a number in base 2. So the equivalent of 67, which is a number in base 10 to base 2, is 1, 0, 0, 0, 0, 1, 1. Base 2. As you can observe this result, you can simply kind of concur that in this our result, which is in base 2, there is nothing like 2 in the result. So like I said earlier, the highest number, if you are working on base 2, the highest number you expected to see in base 2 is just what? 1. So which means your result should be revolving around what? Just 0 and what? And 1. Okay, let us solve another example. Let us solve another example. Again, example 2. Example 2. Convert 35, a number in base 10, to base 2. Convert 35, a number in base 10, to base what? To base 2. What do we do in this case? Since it's a number in base 10 and we are asked to convert it to base 2, it's very simple. This involves just what? Repeated division. After dividing, then we will collect our result upwards as our what? Or the remainders upwards as our result. Now, let's solve. First of all, then 35 comes in, then 2 outside as our divisor. Now we'll divide. 2 divides 35, we are having 17, remainder 1. 2 divides 17, we are having 8, remainder 1. 2 into 8, we are having 4, remainder 0. 2 into 4, we are having 2, remainder 0. 2 into 2, we are having 1, remainder 0. Then 2 into 1, automatically we'll have 0, remainder 1. Then we'll correct our result upwards. As we do that, we will having our result as 1, 0, 0, 0, 1, 1, base 2. This is our result. So converting base 35, base 10 to base 2 automatically gives us what? 1, 0, 0, 0, 1, 1, base 2. So it is very simple to convert a number in base 10 to base 2. Not just base 10 to base 2. From base 10 to any other number involves the same, or to any other base involve the same process. Okay, let's take for instance another number in base 10. Let's also solve a question. Example 3. Another example. Convert 28 base 10 to octal system. Convert 28 base 10 to octal system. How do we convert 28 base 10 to octal system? It is very, very simple. It just involves the same process, repeated division. If you want to convert a number in base 10 to any other base, simply what? Divide the result successively by the base you are converting to. What do we do in this case? We are going to divide 28, which is a number in base 10, by what? By 8. We will start 28 divided by what? By 8, octal system, which is base 8. We are going to divide it repeatedly by 8. Then we'll collect our remainders as our result, as usual. 8 into 28 will automatically give us 3, remainder 4. Then 8 into 3 will give us just 0, remainder 3. So in return, we'll collect our result upwards. We'll be having what? 34 base 8. So 28 base 10 is equivalent to 34 base 8. That is in octal system. So to convert a number from one base or from base 10 to any other base is very simple. Just know it that what? It simply involves repeated division. And if you want to collect your result, it is very easy. Just take your result, or the remainders, the value of your remainders from the bottom to the top as your result, as simple as A, B, C. Okay, so having known this, you can try add this. You can try add this. It's very simple. You can try add this. Number 1, convert 322 base 10 to base 9. Convert 92 base 10 to base 2. Convert 19 base 10 to base 5. So try this and drop your solution at the comment section for assessment. Thank you for watching. Have a nice day, everyone.